Ladies and gentlemen, it is 3 p.m. It is time to start the meeting. Today's Monday afternoon, and it's sunny almost everywhere in Europe. Most of us are getting vaccinated, and summer is just around the corner. And you know what is also here, right here, for the first time ever today, our first ever meeting on human-centric lighting. On the last day of May, we will examine technologies and applications around human-centric lighting. So what does that mean? Let me explain. I dedicate my life to study the properties of light. But beyond properties, lighting also has effects that can benefit the biological, emotional health and well-being of people. For example, intelligent lighting is essential for the automotive industry. We have seen companies like Volvo, Valeo, Marelli, and Audi pioneer lighting that avoids blinding oncoming drivers and pedestrians. World-leading lighting for automotive company Hella will be in the room to illuminate our path of discussions. Lighting is key to creating a mood and even to contribute to the productivity and stress level management in office environments. One of the top companies investing heavily in making healthier workspaces is ZUMTOBEL, to which we will also ask our epic question. We are learning more about the right color and intensity to light urban areas or homes and even the football stadia. In some cities, they are using light for crowd control, directing people away from dangerous situations, allowing emergency services quicker access. LEDVANCE, the network light application company that evolved from Osram, will shed some light on this. And last but not least, is there anything more beautiful in any room than natural light? There is a company in Italy that can simulate the sun into an artificial window that can't look more real. CoeLux will be in the room to lighten the mood while creating new business. So let's bring all these industries together to see what challenges we can solve. If you are also fascinated by the growing market for human-centric lighting, then sign up now and join us on Monday, May 31st. This world is a better place thanks to human-centric lighting. Siri, that's it. Lights off. Hello, everyone, and welcome. Welcome to the show. We have brought together some of the key players worldwide on human-centric lighting. And our goal today is to find business for the companies in optics, photonics, LED manufacturing, packaging, and assembly. Everyone is here with us. As you may remember, EPIC is the largest and some say the most engaging association in photonics in the world. And I'm here representing a fantastic team of people, 15 people who dedicate their life to study photonics and to make sure that every EPIC member is in touch with their potential partners, suppliers, and customers. Together with my team, we organize events, we provide access to a network, we help you raise capital, we have the biggest website to find a job in photonics, jobsinphotonics.com. Visit it, is fantastic. And we also, everybody knows, if you're an EPIC member, you have a long list of market reports available to you. We provide you market data. Today we are almost at the bottom half of our season 4 of online technology meetings. Next week, VCSELs. I can't be more excited about that topic. But today, human-centric lighting. I would like to first of all, acknowledge the support, the amazing support of our media partner today, LED Professional, also Lager Research, which organize conference and also they provide trends of lighting and they provide information about the fantastic world of lighting. Thank you very much, Lager Research, for your support. And today, this event is also supported by our media partner, Medical Device. Thank you for promoting this event to the whole industry. And our sponsor today, the company without which we wouldn't be able to organize this meeting, is in Finland, and it's Modulight. It's a manufacturer of semiconductor lasers. Check out their demonstrator on medical lighting that they do for the interrogation of sensors. Modulight is a fantastic company in Finland, but also a fantastic colleague is my co-chair today, Dr. Sana Amairi-Pyka. Dr. Pyka, what's going to happen this fantastic afternoon?
Thank you so much, Jose. This is a great introduction to a very special meeting today, human-centric lighting. I tried to get the best representative of this field that we have in Europe and beyond. But I would like to show the supply chain of all the companies that registered for this meeting. So we will cover the full supply chain from the system integrators to the component manufacturers, micro and mini and LEDs and luminaires, the optics, the coating, the manufacturer and assembly companies, the lighting control software that is particularly important for this topic. We have also the end users in the room. We will hear from AUDI today as an end user from the automotive sector, but also very important for us is to hear from the system integrators as well and the light source manufacturers. I'm very excited about this meeting. There's one thing we have to remind the people that the companies on this supply chain are just the ones who registered for this meeting, right, Jose?
The whole meeting is about making connections. In these 2 hours, we're going to connect companies like CHT and DOW that make silicones, materials, all the way to AUDI. Let's see how we're going to make the magic happen. And witnessing this magic is also our YouTubers. Hello, YouTubers. Thank you for joining this meeting. If you have any question for the participants, just post it in the chat. But also, if you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-asset.com, and I will be more than happy to make that introduction. Today, I'm happier than usual. First, because the lighting is giving the right mood, but also because, as I said, sun is shining outside. Later on, we're going to see the presentation from CoeLux. You're going to be amazed how real sun can be simulated. But to start this fantastic meeting, we wanted to go to one of the success stories of the European industry. We wanted to have a company that had made a difference interacting with the whole supply chain. We brought ZUMTOBEL. The light source specialist of ZUMTOBEL is Mr. Kenneth Martin, who's here today to let us help him make ZUMTOBEL even greater than already is. 700 members of EPIC listening to you, the floor, and the attention of everyone goes to Mr. Martin.
Thank you very much, Jose. And a very warm welcome from my side. So my name is Kenneth Martin, and I'm light source expert, working for ZUMTOBEL since more than 15 years. And let me share my slides. ZUMTOBEL, what is it? It's a big company with a sales office somehow everywhere, within 23 countries, and we have in principle we cover all the industries, and at the end, this means we have a very high number of variants, so completed by emergency lighting, connectivity and systems, and as well digital and lighting services. So we especially cover the applications industry, retail, offices and education, art and culture, and even healthcare and hospitality. And developing optics is one of our core competencies. So the light distributions are specifically designed for each application and luminaire type. Our lighting fixtures bring the right amount of light to its targets with the best compromise between the optical efficiency versus design and glare. And this is possible due to our parallel development on optics and LED module platforms to fit perfectly to each other. By microstructures on the injection die casting tools, our light distributions get precise and yet smooth, with reduced color shades even while using mid-power LEDs. We know all our LED characteristics and operating dependencies in detail and do make own specifications. So that's how we have a new unique approach on human-centric lighting as well. On top to the even more important question on the right quantities of light with different regions of our within different regions of our field of view, we also take care about the spectral characteristics. Still, being in an artificial built environment, we humans shall get the right light, which our brain and our body needs to work optimal. So the hypothesis is we are optimized on light from nature, in which we evolved for thousands of years. But the light we see, especially the light reflected by our artificial environment, should be more natural. So having bionic features, not for vision, so not for color only. So we go from the conventional sky or sunlight imitation approach to a bionic approach, considering differences in the spectral reflectivity already at the light source level. When talking about the bionic features of the reflected light in nature, I mean two groups of effects on us humans. There is the gap, or there is the green to yellowish light, which most of our photoreceptors receive from the surrounding vegetation. Its spectrum covers still smoothly the full visible range. So here, full, I see you, pointer. So here you see, sorry, back here. It covers full visible range, this light here, and at the end, it has small but significant also violet contents, and visually, so important for our habits, it has similarities to neutral to warm white or warm white light. These dashed lines here, yeah, and but our intrinsic photosensitive retinal ganglion cells, so which drive the non-visual effects of light on us, are stimulated persistently by the bright light of the sky, or of the sky and its azure contents here. Even if it's only in small parts of our field of view, or if we sometimes only look up, as we don't have the strong big surfaces contrasts between the sky and the natural ground in our interior artificial spaces, with mainly neutral surfaces like white walls within our spaces here. Those features might be combined within one special or specific spectrum as well. So indeed, there is a trend to reduce non-natural spikes in the LED spectrum, to reduce them in the past, mainly to get the highest color rendering values. It also helps to not only optimize it for the theoretical average observer, but to any individual and even animals and plants. Our so-called ZUMTOBEL spectrum, the red curves here on both sides here, it has a very good color rendering, but not the highest values. This is because it is made to be non-visually more effective, like the cooler sky daylight spectra, and similar to the natural daylight approach with a smooth, low blue-violet content, but high azure content, and at the comfortable visual color of the light. And so this, epic light source was co-developed with the biggest LED manufacturer in the world, Nietzsche. And but for our further planned development steps, we are looking for big-scale injection moldable polymer materials and silicone types with similar thermal properties, such as polycarbonate, but with optical features near to those of PMMA and methyl silicones, having a high refractive index with lowest absorption and longer transmission rate lifetime, down to at least 400 nanometers, which also should be suitable for the upcoming high radiant power applications. So this is a presentation. Thank you for listening, and I'm curious for questions.
Thank you so much for this very nice first talk today, and for presenting the epic question nicely. Let me just push a little bit in there, because I want to understand a little more. What are the major limitations you find when you try to adjust these curves and lower the blue side, the non-natural peaks? Is it more on the LED side, or what are the limitations today?
Yeah, it's mainly on the LED side. So to combine the features which are needed, like long lifetime, efficacy, and as well also to make a light source which is very suitable for the optics as well. Yeah, so to have a very good mixture on the light emitting surface. This is important. You know, all your optics guys know, if you have a light source which has different colors of chips inside. And together with lenses, this can make color shades and so on. This is difficult, but this is solved with this light source. And yeah, this is.
Yeah, I have a first question for you from SUS Micro Optics. Wilfred?
Yeah, I have a question for the color temperature that you showed in the beginning, with reflected light and natural sunlight. So I thought it was around 5,600, the color temperature of natural light is, and you show 4,000, 8,000, and even 15,000. Especially at 15,000, I mean, you have a very strong UV component. Does this have also an effect on the materials? So basically 2 questions. And yes.
Yes. So on the one hand, we have compared the daylight spectra with the LED spectra. So the LED daylight spectra is clear. This has a very strong UV component, and we are always within the LED spectra. We are always trying to stay within the visible region, so that we don't go too far into UV, which we can't see and which is absorbed by our lens, and that's why UV is getting a little bit more difficult, or the violet content, as I said, down at, we have a peak wavelength there at about 425 or 420 nanometers. This already gets a little bit more intense to the materials. That's why we're also searching for better materials here.
I see another question from Osram. Pim?
Hi, Kenneth. Yeah, I have a question more on the light source side. So you're talking about a violet peak, which leads me to believe you're using LEDs which are pumped by a violet dye plus a phosphor mix.
Exactly.
On the other hand, you also mentioned that you're combining somehow multiple colored LEDs inside your light source. Which approach is taken here for this new ZUMTOBEL light source that you're creating?
No, this is completely made from phosphors on top of violet chips.
And that's for stability reasons then more, I assume.
It's so to have really a smooth spectrum, to so that we don't have some spikes, some peaks there inside, so that we are very close to natural. Because to really, I mean, you could also make like in former times, like fluorescence. You can also make some very hard peaks inside the spectrum. But at the end, this is good for an average observer for calculation. This is perfect. You can calculate highest efficiency and so on. But the question is really if any individual really has the same appearance of the light at the end. And yeah, this is
You gave us a list of challenges. I would like to let Jose.
Yeah, this meeting is about connecting. This meeting is about connecting. He came here with an epic question. He's looking for injection moldable polymer materials and silicones types. And actually, I was expecting this. So last week, together, Antonio Raspa and myself worked hard on bringing the 2 main silicones manufacturers in Europe. We actually have CHT and DOW in the rooms, presented by Sabine May and by Francois de Boule, respectively. So I would like to have a quick mini, because time is always a constraint, mini debate of how we can help each other. So first, Kenneth, when you show this slide, we are talking about high refractive index. Do you have some number on that? Because high refractive index can mean a lot. And
the higher the better. That's clear. No, I mean, metal has a little bit a low refractive index. I think that's why that's why the efficiency drops with this. It's good for lifetime, but for example, a phenyl silicone index, or sometimes it's a mixture now, but in this region it's better, but the absorption in the violet is stronger with phenyl silicone, and this makes some difficulties in lifetime or in lumen. I mean, we're talking here about lifetime of 50 to 100,000 hours. Yeah, so it shouldn't have more than 30% of degradation in this time. And
the challenge is on the table.
So,
Let's go first to DOW. Let's go to Francois de Ville. Francois, good afternoon. How can you help my friends from ZUMTOBEL?
Well, first of all, I'd like to understand, you speak about here the LED package, so the dye protect with, a silicone, most of the time recently a silicone component, I mean, to protect the dye and the phosphor layer. Is it what you speak about here, or do you speak about a secondary optic component? I mean, it's not totally clear what you want to achieve here.
Yeah, but what I mainly mean, so because I'm the light source specialist and specifying also the material somehow for the LED. So that's true. I'm mainly talking at the moment on the light source itself, on the LED. But then in the next step, also the lens is very important there. The lens that is put on there. I think those are different materials to you have to make different molding things and so on.
You two need to have an offline discussion.
Yeah, I think
after this.
Complicated,
But I do believe, because I know the DOW products quite well, I do believe that when it comes to absorption, they have something that can actually be matching this. But Francois, maybe correct me if I'm wrong. This is something that you could really help, right?
Yeah, well, yes. I mean, we already offer, I mean, a range of optical grade silicone for secondary optics application. I mean, in parallel to thermoplastics, well known and widely used as well. So I need to understand if you want some sort of modified optical grade silicone that may filter one or another wavelength to, is it that you're looking for, or is it different? I mean, that's the question.
I mean, we're making tests at the moment for the secondary optics. It's less on silicone because they're more difficult to mold to fit into their right exact form. On the lens level, it's more different polymers. So more the stiff PMMA-like polymers. But on the LED side, seems to be a difficulty to get really high lifetime.
I think you had to have an offline discussion, but I want you to also meet another person that has very recently joined our friends group here. Sabine May is coming from CHT. Sabine, is there something that you can help here on the well, you have optical grade LSR called the SILSO clear. So is that something that you can help on that particular challenge? High refractive index and low absorption in the lower wavelengths. Sabine is with us. I don't know if we can hear her. Yes. Sabine? I don't know if you can hear Sabine. I think we have an IT problem, which is okay because we make this show live and that's the beauty of it. Sabine, I'm going to come. Sabine, yes.
We can get back to her a little.
Yeah, the polymer, the silicones of CHT are much better than the internet connection they're having today. So we'll come back to you, Sabine, later. But there is a question in the group all the way from ABC Engineering. Sandeep, what's on your mind? Please unmute and tell us what you want to ask our friends from ZUMTOBEL.
Yes, good afternoon, good evening. My question, we are into LED lights, mainly supply, but we want to also offer human-centric lighting as a part of lighting design. So my question is, if you want to install human-centric lighting in a showroom for general lighting, not for task lighting or the product lighting, only for general lighting where people see it move or just wait. So in that scenario, what could be the correlated color temperature, say from 10 a.m. to 8 p.m. And as well as in the office scenario? Can you please guide us?
I would say don't go too high. I mean, if you see what's coming down from the sky, normally if you measure this, this can have up to 15,000 Kelvin. But we have lots of customer who really, if you give them too high color temperature light, then they're getting crazy. So this is sometimes just too bright and too. It depends on the walls, on the reflectivity of your surroundings. So if you have a more natural surrounding, a more warm surrounding, and so on, then you could also go higher. But yeah, you have to be careful, because at the end you don't have this. Yeah, it's difficult to really imitate natural surfaces, because often it's not really natural, this surface, if you look at the detailed spectrum then.
Yeah, I understand, but if you can kindly specify the CCT absolute value, it will be better. From what to what range? So
yeah, for example,
in the morning, in the morning, what could be the CCT? Say 10 o'clock to 1 o'clock, and maybe 1 o'clock to 5 o'clock, and maybe 5 o'clock to 8 o'clock. That would help.
Yeah, something like, depends on your light source, how much melanopsin it's, or which is the MR ratio and so on. So you can go up to 5,700 Kelvin, for example, but it depends. If you divide the light of the ceiling and of the ground, then you can even go higher on the sky and lower on the surrounding, for example. So depends really what you can do with your light sources and so on. But normally I would, a standard is 4,000 Kelvin, staying on this as a basic, but then pushing out sometimes dynamically higher to up to 6,500 Kelvin.
Okay. So in short, you mean to say that in the morning it could be about 6,000 or 6,500 K max, and in the afternoon or in the evening it can be 4,000 K, which is a neutral white color.
For example, yeah.
Okay, thank you very much, sir.
Kenneth, we have reestablished the connection with Sabine May. Sabine, when you see this challenge, Kenneth joined these meetings to solve this challenge. When you see this challenge, can CHT help on this matter?
Yes, hello. I'm sorry for the bad reception.
Never apologize. It's the internet, not you.
Yes. Yeah, actually, our material.
You know what happens when you make a show live? These things all the time, and we keep them with a good smile. My good friend Mark Juarez from Seoul Semiconductor has a very good question for Kenneth. Mark, what's on your mind? Buenas tardes.
Buenas tardes. Hello, everybody. So thanks a lot for the invitation. And I see great people here from Human-centric. So I would like to know, why do you think is still not really massively adopted, the human-centric light?
Yeah, because up to now, I think human-centric lighting was an umbrella for everything somehow. And so this was, in last time it was, okay, you need tunable white, then it's human-centric lighting. And now it's, okay, melanopic ratio or melanopic daylight efficiency index and so on. So all this number crunching is, yeah, it doesn't reach really the people. So it's difficult, I think. Yeah. So you also have to go into the emotional topic inside, like you did here as well. I mean, you were the first was who really pushed this sunlight approach. This is really making a very smooth spectrum. You pushed still for the high color rendering index, for the maximum color rendering index, and yeah, this is the evolution at the end. But still, we have both difficulties, yeah, to reach really the high efficacy. That's clear, because the efficacy is at the end, it's luminous efficacy, and the luminous efficacy means V lambda curve, V lambda sensitivity has to be calculatory high, and yeah, this is.
Kenneth, Mark, stay with us. We are going to go to the next speaker, another success story in the European ecosystem, a company that came up from Osram, LEDVANCE. Dieter Lang is the R&D expert of human-centric lighting at LEDVANCE. He's going to tell us also how we can help LEDVANCE with those 700 MEMS even better than already is. The floor and the attention of everyone goes to you, Dieter.
Thank you. Am I already sharing? So
not yet. Yes, it's coming now.
Not yet.
Perfect.
Okay, you see the full screen? It's the right one?
Yes.
Crystal clear.
Okay. Thank you for this opportunity to present on human-centric lighting. Hello, everybody. I've seen some names of people I know well in the list of attendees. My special greetings go, of course, to those. And I hope to see you all in person soon, sooner or later, better sooner than later. There is a widespread agreement, and we have already heard some common understanding on basics related to human-centric lighting. Nevertheless, I want to repeat a few topics because I think not everybody in the audience has maybe all that knowledge about human-centric lighting. So why doesn't it move? It should, yes, okay. We are spending too much time indoors, that's clear. We are deprived from natural daylight. We have too low light levels. And we have too high light levels at night. These are some well-known things. And this is also related to issues like a reduced performance, like fatigue, like sleeping disorders, and in severe and worst cases, even to depressions. And the solution of this is to have more light, but it's not only quantity, it's also a question of quality, of course. Nevertheless, the first step is also to have much more light during the day than we currently have. Human-centric lighting is not only targeting for a specific biological effect, as some people thought in the beginning, 10 years, 15 years ago. HCL is always a holistic approach which includes visual, emotional, and biological of light on humans. And the target is to provide the right light at the right time. And to achieve this, we have to consider all the different living and working situations, and the light should be adaptive to the right situation and provide the right light for that right time. We know that there's also a common agreement that natural daylight is kind of best template for lighting during the day, of course. And we know that we have different photoreceptors for the visual effects of light and for the non-visual effects of light. And daylight is providing light for both effects simultaneously and does this in the best way, which is very difficult to mimic by artificial light. And we all know what's clear, but nobody often talks about this. Daylight is not static. Daylight is changing. And at sunrise, for example, or sometime before sunset, you have a completely different spectrum. You have much less blue components in the light. And so to mimic this with artificial light, you need at least two different light sources. You need one with a higher bluish light content for lighting during the day. And you need a second one with a reduced bluish components for the light, for the night and evening lighting. And of course, you can't switch hard between these two extremes. You need dynamic transitions, and these dynamic transitions need to be smooth and they need to be intelligent. And after this introduction, I want to come to the system we have developed for this. The system should be automated. The system should be intelligent. No user should be required to think about what is the right lighting, what do I need now, and how do I turn the color temperature, how do I turn the intensity, probably on a touch screen where I first have to select change intensity and then change color and then not finding the right menu and at the end coming up with a situation that was not intended. So we are offering a system which consists of different luminaires which are controlled wirelessly by an automated control unit, and the commissioning is done via an app. The app is not needed later for operation. So during operation, the interaction is only between the control unit and the luminaires. And that control unit provides not only a curve which claims to be dynamic and daylight oriented, as indicated here, but it allows the user to select between a multitude of different dynamic operation modes. And this is symbolized here in that case by just rotating that wheel You can select any of multiple curves which are overlapping here in the diagram. And at the end, they are all daylight oriented, but they guarantee to meet some basic requirements for human-centric lighting. This is no wrong light in the evening and at night. Even if you go to boost mode, you will have a reduced brightness and a reduced color temperature in the evening. And so this system does it all automatically without any user, any need for the user to think about what he's doing. It just rotates, it's intuitive. So this system is quite simple. It is installed in standard wall-mounted switch boxes. Commissioning and setup is quite intuitive and automated. No programming is required on the user side or on the installer side. That's a very important advantage. And I think with this, we come also to the claims we see for the future. It is not so much related to the LED. I think we have a lot with LED quality already achieved. We have kind of full spectrum LED. We have LEDs with very high color rendering. Some improvements in the efficiency are of course required. This is a way which will be continued, and of course we are expecting progress in this. I see the most progress to be made in direction of controls. We have already had a question on this. Why is human-centric lighting not yet adapted by many people? And I think it's too complicated. Still, the user doesn't know what to do. The installer doesn't know what to do. Even the lighting designer doesn't know what to do. At which time should I have a certain intensity and a certain color temperature? And we need to take all these questions back to intelligent controls, and these intelligent controls need to make it correctly. That means the time zone, the setting, the sunrise, the time of sunrise, time of sunset, all these things should be included in the intelligence of the system. We probably need more integrated components which are made to answer all these questions which a standard lighting designer, a standard user cannot answer. But these are no secret things. These are well-known things. They can be calculated and they can be adapted in components. And these components are not available. And each company bringing such a system to the market has to spend a lot of energy and time and programming experience to realize such systems. Also, protocols like DALI or ZigBee don't have yet the right functions for a full automated daylight system. And from companies, of course, also from all companies here available now in this audience, I would expect that they are not only talking about human-centric lighting, but also living human-centric lighting. How many of these maybe 50 companies have a human-centric lighting installed? Maybe 10%. So they should not only talk about, they should really do it and experience it and then talk about their own experience, and that will convince the customer much more than only presenting.
Peter, you know, the only way is to communicate, to raise awareness. And that's what we are doing today, but also to help you, because if human-centric lighting is going to be a success, it's because of companies like ZUMTOBEL and LEDVANCE who wanted to open the show today. You have a challenge, and I love challenges. This is for me the highlight of the show. When you come to me, when you come to an epic event saying, I really want to work on finding a high quality LED with a full spectrum, high CRI and high efficiency, actually. So is there anything else that you can share on that? Because I already have Osran raising the hand.
Yeah, yes, of course. But many of the people in the audience will say we have this, and indeed the quality has increased a lot over the past years, and we have excellent LED. We have excellent LED with respect to color rendering, to very similar like daylight. We need them to be a little bit more energy efficient, and that is one step, and I'm sure this step will come. But on the control side, I see more challenges than on the LED side, to be honest.
Wim from Osram, what's on your mind?
Yeah, Dieter. So first of all, you know, we're working always on the efficiency part, on the efficacy part. So that
Yes.
will come, hopefully.
Yes, I'm expecting this.
Slowly,
but it comes.
It comes. I had a different question. So both you and Kenneth from ZUMTOBEL will also in some ways talk about human-centric lighting as changing CCT over time, mainly. Are there any thoughts in the way of keeping a constant color point, so keeping your color impression constant, but changing some parts of the spectrum, for example, the part that's influencing the production of melatonin in the course of the day to suppress melatonin production or to increase it depending on your wake-sleep cycle and so on, without actually changing the impression of the light in the environment?
Yes, there have even been several studies on this, and it has been shown that there is a limited possibility to achieve this, but the limits are quite, let's say, restrictive. If you want to have very high color rendering, this is one condition which is, of course, required. Some studies have claimed higher than 80. I think today nobody needs to talk about human-centric lighting with higher than 80, so we need to claim higher than 90, maybe close to 95. And then the restrictions become even harder because all that these options for spectral engineering are getting reduced if you add more and more boundary conditions like meeting very high CRI. And I don't expect a large potential to cover a range, let's say from 3000 to 6000 Kelvin. Sorry, to cover the effects, which I would usually cover with a range from 3000 to 6000 Kelvin with a constant color temperature and just a little bit spectral engineering. I don't expect that this will be possible. I never say never, but
we have some of the best LED manufacturers in the room. Osram is here, so Semiconductor, Luminus. I really want to find these connections, but many people in the chat are asking about what is really human-centric lighting, how does it work, how does it operate. For all of you, I have a present. We actually have a reputable person, very well-known person who knows this back and forth. Good Light Group, Mr. Jan Denneman. For those in lighting who know how good I feel when I mention this name. Jan Denneman, good afternoon.
Mute. Yeah, hello, yeah.
Good afternoon
all, yeah. I see many friends, it's also Dieter, yeah. And Dieter, you hit the hammer on the nail, I have to say. One of the things is that good light companies, they mainly talk about human-centric lighting, but they don't do it. Yeah, the penetration degree today in the market of good lighting solutions is neglectable. The consequence is that more than 5 billion people today have to work in biological darkness. And we know for already 20 years, yeah, that's not good for sleep, not good for energy level during daytime, and not good for mood. Yeah? And I like, for example, what LEDVANCE is doing is making modules available so that indeed human-centric lighting can be made more simple. What we do with the Good Light Group, that's a non-profit organization, yeah, we thought about how to change the world. And perhaps can I share a couple of slides quickly? Is that
Jan,
doable?
my meeting is your meeting. I'm so happy that you're here. Please share the room. Okay, because everybody needs to know what human-centric lighting is to do business on it, and I couldn't find a better person to define such topic.
Yeah. Can you see this now?
Yes,
my screen?
Crystal clear.
Yeah? Okay, good. Yeah.
Also, please keep it brief because I don't make
sure,
time.
I do it. Yeah, no problem. Yeah. So the key insight is that
you can go slideshow mode. So you click on the slideshow mode. Yes, there. Yes, better. Perfect.
Yeah, you can see this. Yeah.
Yeah, you're sharing with us the grown screen. So go to Weergabe Instellingen and switch.
Okay, yeah. So we spend 90% of our lives indoors, and there indoors we're deprived from natural daylight.
Jan, you're sharing with us the
Sorry?
wrong screen. So you are sharing with us the one for the presenter. So
Okay.
you just it's okay. Just click on. No, follow my instructions. It's very simple. So go slideshow mode again.
Yeah, I'll do that.
Yes, and now we're gonna switch the screen. So go to Wiedergabeinstellingen. They're in front of you. Move the mouse icon up. Okay. Okay. Yes.
Yeah, my question is, I'll do it in this way.
You know, these are the kind of things that when you make a show live, make my life entertaining.
Yeah,
Otherwise, it's every day the same.
But Jose, we can all read it.
Yeah,
That's okay. We can all read it.
Yeah, you can,
but now Frank
it,
from NTS, you can read it better. So go ahead, Jan.
Okay. Yeah. Okay. Yeah. So the solution is what I think that first of all, let's talk about a simple term, good light, and not human-centric or biophilic light. In the same comparison that almost everybody in the world knows that good food is important for your health. But nobody knows that good light is as important for your health and well-being. So that's the reason that our non-profit organizations start talking about good light. And the solution is get daylight. That's for everybody, of course, since we all have an indoor job, or most of us. So we need to have indoor light that mimics the daylight situation. And to put it in a more business perspective, the focus of the lighting industry and also the semiconductor industry is now on their customers, and that's an important thing to do. But the value today, for LED and semiconductor solutions for lighting, they come mainly from cost reduction, energy saving, cost reduction. And the consequence is that we give minimal light indoor, 500 lux horizontal maximum in a static way to fulfill the visual requirements. That market globally is 70 billion and shrinking very fast because the focus is on cost reduction. The efficacy of almost all LED systems is equal. So the only way to differentiate your company from another company is playing with the cost. The alternative is that instead of thinking of customers, think about the users. And there are more than 5 billion users on Earth that are deprived from good light. So the value in the future should not come from cost reduction only, but should come from user health and well-being. One of the most important things is that we need to crank up the lux levels during daytime, and make that in a dynamic, controlled way. And then I'm sure that the total industry will start growing again on a world scale. Yeah, that's my simple, quick contribution at this stage. Jose.
Thank you very much for this fantastic contribution, and thank you for being at the meeting today. We want to come back to you about market questions, but there is a lot of people who want to ask questions to LEDVANCE. So I want to go first to Actar DE, a provider of suppliers of black coatings. Alexander Tele, what's on your mind?
Yes, hi. So, well, we are dealing with absorbing light, so maybe it's not not our topic today, but I'm really curious. What is the state of research? So, is it known what needs to be done? So, as the speaker said, just switch to natural light as much as possible, and that's it. Is this the state of research?
Yes, I think this is basically one important point of the state of research. It does not mean that's everything. It's not only, of course, the intensity and the color temperature, it's the light distribution in the room. At the end, the light should be hitting the human eye in the same way as it is achieved by natural daylight, because we have, of course, also other constraints. We need to work glare-free in an office. We can't have these high luminance levels as we have outdoors. We also don't need them. So outdoor light levels are not always the best, not for every situation, but it gives a good orientation. And I think basically if we orient on not natural daylight as we experience it outdoors, that's a good approach. And experience is not only quantitative, it's also a kind of emotional experience outdoors, which we have to try to bring indoors. But essentially, in comparison to what we have now, are the differences in intensity and in color temperature over the day.
Dieter, if you ever look for a partner to develop absorption panels after the best coatings, the best black coatings that I know of, but also also Mark from Seoul Semiconductor, I think he has some room for collaboration on the LED side. Mark, what's on your mind?
Yeah, coming to the question about the studies. So since 2018, that Seoul launched the Sunlight LED. So we've been collaborating even since before with great universities like University of Basel from Switzerland, Harvard University from US, and Singapore University, where we try also to give them our preliminary products, our newest products like the Sunlight in advance that they can test with humans or with animals. And right now we are starting to have the first really positive results, especially from University of Basel, where they test about the sleeping, that if you receive a good light during the day, you can have a better sleep in the night. And now it will be published, the new one from Harvard, that this is also very, very interesting. And another one in Singapore talking about the myopia, because as you know, the glasses is a big market. And the influence on this is the light, especially. And it's been demonstrated that the quality of the light will have also a big effect. On,
Mark, you're here representing Seoul Semiconductor, one of the giants on the LED manufacturing. There is so many things we can do together. Thank you very much for supporting this event. We have another question from ZUMTOBEL. Kenneth Martin, what's on your mind?
Yes, my question would be, we are always talking about very high lux levels on the floor when we go outside. Yeah, it's true. There are like high lux levels, but I think we often perhaps measure it wrongly in this. If we talk about vertical lux levels, why lux levels? Why not luminance? I mean, okay, it makes it more complicated, but it's better normally. Our eyes are something more like a multispectral imaging camera. Yeah, and it depends how many photoreceptors in our eyes are stimulated, and not how a cosinus corrected receiver senses the light. This is completely different, I would say. Perhaps we have some guys from measurement in the as well here, so from spectrometer measurement and so on.
I'm going to address that with a little debate afterwards, because now I cannot wait anymore, because everyone who knows the next company knows why I get so excited. We are going to go, for those who you don't know, CoeLux, get ready to see something really, really, really special. Paolo di Trapani, buonasera, grazie mille for being with us today. The floor and the attention of everyone goes to you. Show us, illuminate us, make us half as happy as already am. The floor goes to you.
Thank you, Jose. Thank you. I hope everybody see my screen.
Yes.
Just I have to connect it out. Just a second. Yeah, I think I would like to contribute exactly to the focus of the discussion about the experience of the light and the natural light. So our payoff is experience the sky. Even though that's a common experience, not that obvious to interpret that. And I would like to draw attention to a few relevant aspects that we believe are essential for the sky experience. So the first one is the vertical experience, meaning that the sky is above us. So even though you have a beautiful window and beautiful landscape, as long as you have a ceiling, there is an issue, because that inherent and natural vertical connection is broken. as everybody can experience, if you drive a cabrio or a car with a panoramic roof, and then you go back to a standard car, immediately notice, you understand what I mean. So vertical is number one. Number two is that the sky is infinite, meaning that it has an infinite depth of view. If you Google happiness, you find this type of pictures. And why it's so important that infinite depth? If you Google elevator or elevator movies, you find horror movies, and this is the snapshot from Shining from Kubrick. Indeed, the absence of that depth is, in my opinion, linked to the survival instinct that teaches us that if we don't have an escape, we're in a serious danger, potential danger of being eaten, actually. So it's a bloody death, what we are unconsciously afraid. Kubrick is a genius in that interpretation. And the third thing is that the daylight and the sky signature are actually, is a paradox, but the signature of the daylight are the shadows. So shadows, they are not just absence of light. This is the light from the sky, which has, of course, a lower illuminance and create a lower luminance on the shade, on the shadows. But that's at least 20% up to 100% in evening. And the gap in chromaticity between sun and shadows are those that creates the effect of the, makes the evidence that the sky exists, and even of the timing during the day. So shadows are essentially in creating the perception of natural light. And finally, the light, the natural light is not always the same. So the natural light in the outdoor creates those shadows, but even if you have the real natural light, on, for example, on a skylight, because the sun hits, enter the hole and has the same illuminance as in the outdoor, but the skylight does not the same because the aperture is much smaller due to the huge divergence of the skylight. And so even the real sky creates indoor shadows that are black and gray and dark. So when that's appearance of the indoor natural shadows makes you feeling that you are still into the box. And so the last point, it was mentioned, is the dynamic effect. But when we talk about the change, we have to keep in mind that the sky and the sun, they have different intensity and different luminance, different color spectrum. And both of them, they change, for example, in the color during the course of the day. These are the data for the sky, and these are for the sun, measured data in the outdoor. And so if we pretend to get the effect by having a source which has a common spectrum, as also was mentioned by Martin from ZUMTOBEL, it is clear that we might resemble what happens in the outdoor in an overcast day, when both the sky and sun have the same color, whilst in the clear day, there is a gap, and this gap shifts both the color, both the CCT during the course of the day. That's very important to have the dynamic effect of the real daylight. So coming to CoeLux, of course, we offer these solutions that might provide the experience of the sky, not only if you are in the penthouse or nearby to the ceiling, to the roof, but in any place, it doesn't matter what you are above. But what ourselves, we have been surprised that even in the presence of large windows, for example, here you have good windows, but unfortunately is a cloudy day, the presence of a sky above you and the luminous and bright sky triggers your mind, your brain to the memory of the outdoor, and that installation deals in keeping with the real windows, and therefore create in the brain an overall experience of a sunny daytime. The depth of view, so the optical component that create the infinite depth of view, as shown here for an observer that moves below a CoeLux skylight, is essential, because it's not just the image, but is the three-dimensionality, so the directionality of the light, what really makes the effect. Yeah, and ultimately, it's important that supernatural characteristic of the shadows, because these are a real shadow, which is, of course, bluish, but a little bit gray. And here, when you have the CoeLux, is much more It is the shadow that is reproduced artificially is the same as the shadow you experience in the outdoor because of a different parameter of the luminous system. Yeah, an effect is clear. So when you have a room and then you have this artifact and you switch on the lamp, so you really feel the box that closes around you. And that's my last slide. The dynamic effect can be reproduced. This was shown in Neurolution. It's going to be launched in a few months. If instead of the scattering produced by static nanoparticles, liquid crystal nanodroplets are used, it's possible to control the amount of scattering electrically, so to tune the amount of scattering like the sky and the sun are doing the real atmosphere because of the change of the path length. And so it's possible to achieve in the noon or even in time exactly the same change of scattering, so change in chromaticity of both the sun and the sky component, up to create this super real paradox of a zenithal sunset, so where the light is vertical, but still it's possible to switch from noon to sunset time to get your brain, your memory to resemble what you have seen in the outdoor, but probably never noticed, which is the color and the experience of the sky. So the artifact indeed works very much like an artwork to get you reconnected with the experience of the outdoor. Thank you.
This is wonderful, Paolo. Very nice technology. And I see here that you have already some fine people who say that this is not given enough justice to what you do. When they see you in a showroom, already have a nice comment from Mark from Seoul Semiconductor, and Jose, of course, who also knows all the movies, by the way. Let me tell you how it goes with EPIC. You tell us what you do, but we also you have to answer the EPIC question. We know what you can do for the others, but what can the others do for you? Is there any challenges or new solutions that you're looking for?
Yeah, of course, there are many cooperation that are possible. So we are struggling and dealing with the reducing the cost and thickness and complexity of the device. So of course, all the development in the reduction of size of all components. So starting from the LED, so going to micro LEDs or all the micro optics that can be created on big area elements are essential to boost the technology. So miniaturization is the must, because the reducing the size of the product, finally the raw material are just plastic and LEDs, so there is no gold, no platinum inside. Of course, once the investment for the scale up is done, so the final price is just because of raw material. So as for the electronics, the cost has been reduced a lot by miniaturization. The same will be for the CoeLux solution.
Yeah, regarding the thickness, I already have the question from Seoul Semiconductor on what is the actual thickness of the system that you have?
Yeah, for what is available on the market is 25 centimeter.
25 centimeter.
Yeah.
All right. So let me hear the question directly from Arno from V Research. Arno, what do you have in mind? You can unmute and just ask.
Yes, thank you. Hello, Paolo. My question is about how do you synchronize your system if you have a window with the sun outside so that the shades are going in a similar direction, or if you are having maybe two of your systems installed within one room? Is that already possible? What electronics do you need, or is it currently a problem?
No, I can answer. That's a very important question, because we use synchronization by I mean, the control can be done by many control. We have the DALI system can be controlled by Casambio, but the issue, we have to be quite careful, because I myself was for many years trapped into the idea that we have to create something that people believe is real. This is not the case. It's a surreal effect, so it's an artifact, and you don't really So, for example, I can quote studies done by Brunnberg. They, with hundreds of people, they study CoeLux in comparison with the standard illumination, both in winter and in summer. And in both cases, CoeLux was overcoming the standard lamps, not for the feedback on the people, how they commented for all the parameters. But the gap was much higher in winter. So when outside was cloudy and raining, the people prefer the sunny artificial day more. So meaning that you don't really need to create something that pretending that is similar like in the outdoor, the same direction, the same time. It is something that makes you happy. And that's maybe here related to the experience you had of a sunlight maybe 100,000 years ago, not now. So we are suffering from something which is maybe not real. The fear of a lion or a tiger might eat us if we are in an elevator. There are no tigers, no lions. And this is unconscious fear. And we beat that unconscious fear with another not real light, which is not created by the sun, is not at the outdoor. You know that you are inside the elevator, but nevertheless, your earth is going slower, your earth rate variability increases, you are sleeping more during the night, you have a lot of different measurable parameters that clearly show that the impact of that artifact is real on your happiness, on your well-being, and even on your health. So we have to be very careful. We are not doing a Truman Show. We are not cheating the people, pretending that they are. We have to be clear that's an artifact. We can make the moon in daytime, and we can make the sun shining during the night. Depends on what is really useful.
Thank you, Paolo. And we have a lot of questions, but let me go back to the matter of the thickness and micro-optics. We have a question from SUS Micro-Optics from Wilfred. Wilfred is also a partner in the European pilot line on freeform micro-optics manufacturing, Fabulous, that started in January 2020. What is your question, Wilfred? Maybe you can directly ask Paolo. Sorry.
Yeah, thank you for Sana. It's everybody who has seen those lights I talked to are blown away. So this is, and everybody wonders, how can we make it thinner? So really, the first time somebody told me about your lights, I think it wasn't even official, that it was 2-3 years ago, and they said it's just unbelievable, the effect of your lights. But then the next question was, or the next statement was, but they have to get thinner. So, but I don't understand yet, what is the optical or technical challenge to get them thinner? So what is the reason? Is there a technical reason, or is it just a cost reason, or can people live with that thickness? I think in a building it's okay, but if you want to get into cars or something, or into other smaller spaces, it might be more difficult to do this.
Yeah, that's correct. Of course, we have to. I mean, we are working on that. We are not just staying with the current products that are visible are just a small part of our activity. So we are a research company. Of course, we are dealing with all these issues. You are right. For the residential, might be okay. No, already. In fact, already this 25 centimeter units is bought by people, not that buy at home, they install by themselves. So they might prefer to be thinner and cheaper, but okay, it's already okay. Whilst there is a very big interest for all the transportation, from aircraft, trains, elevators, shipyards, and even cars. Yeah, because whenever you have a limited space and people stay a long time without moving in that space, that unconscious fear becomes dramatic. And yeah, in that case, miniaturization is indeed a must. And therefore, yeah, the challenge is to handle with many layers. So it's not just you have to create so the light is not just the non-imaging optics, because you don't have just to create illumination. It's not just the luminance, but the luminance, the parameter you have to control. So you have to control phases of the light, and therefore you need quality of the optics, like basically in photographic issues. So you have to control very well the surface on a small component. You don't have to to see the pitch, of course, and you have to handle over say, square meters, not just on the size of a wafer. So you have to switch from wafer optics to big size optics and to keep aligned many layers. Basically, it comes to using the technology that are used for display industry into the lighting. So it's a transformation of some industrial pipeline from some different application.
Paolo, we have all these guests in the room, but we also have a lot watching us on YouTube. Jose, you are following our guests on YouTube, right? Do you have any questions?
Yes, I have a question all the way from Finland. The company Optical, who made molded glass optics, they say, I want these windows in Finland, especially in winter, but you also wonder, do you have collaborations with software companies? Does software play a role on these windows of the future?
Yeah, we have, of course, some partners, but not that developed as for the hardware. So I think that's a good idea. Jose, thank you very much for triggering this, because ultimately is the connection between people and the technology. And CoeLux is not a solo player, of course. When we talk about the smart home, the home is not just the house. So the home is the place that you inhabit, and ultimately the people inhabit the cosmos, not just the house. So that means a connection between different technologies that all together play like in an orchestra to create a performance, because the architecture is a theater, is a performance. We have to stage the experience of inhabiting some living space. And
Photonics is a digital technology. Photonics is a digital technology. Paolo, we're going to make a lot of introductions for you, but I want to say I am still amazed, and I can't wait for the next Light and Building show, one of my favorite shows worldwide, Paolo. In the last Light and Building show, I was also amazed, blown away by the booth of Lumileds, not only for the LED that they proposed it, but also because of the level of AI, the level of software that they are bringing into the lighting of the future. That's why today we wanted to have Lumileds in the room, and represented by Wouter, Soer, Director of Illumination Product Development at Lumileds. Thank you very much, Wouter, for being with us today. Tell us how we can help Lumileds be even greater, even more fantastic than it already is. The floor is yours.
Thank you, Jose. So let me share my screen here and get started.
I can't wait for the next Light and Building show. Oh my God. I can't wait for the next show. I cannot stay here anymore.
All right, can you see my screen?
Crystal clear.
Okay, wonderful. So yeah, Lumileds is a manufacturer of LEDs and LED modules for general lighting, but also for automotive and mobile devices and other applications. So yeah, I'd like to add my perspective from that background on how we can make better light sources for human-centric lighting. So human-centric lighting in a way is about meeting both visual and non-visual or physiological needs, right? So in traditional lighting design, a lot of the focus has been on meeting visual requirements like luminance uniformity, color quality, and glare. And when you do that, you get like lighting that does well on those aspects. So it performs well for seeing things, for creating a certain atmosphere, maybe, but it does not necessarily result in healthy lighting. So you may get not enough light during the day. So we work, for example, in dark offices, and oftentimes we get too much light during the night or in the evening, right? So we work on devices. You may get light coming in through your bedroom window. So we need to take those things into account as well, and that's really an essential aspect of human-centric lighting, that we include our non-visual requirements. And as has been mentioned by some of the previous speakers already, so one of the ways the way we measure this is by melanopic EDI, so melanopic equivalent daylight illuminance, which is basically the exposure of your eye to this melanopically weighted light. And so when you do that together with the other application requirements, then you get light that not only makes you see well what you need to see, but also supports healthy circadian rhythm. So you can have more light during the day and then gradually decreasing into the evening and supporting your circadian rhythm. Right? And so the recommended levels that comes from this from this international workshop that was held recently. So this is like a big group of scientists that came to this consensus that we need a melanopic EDI exposure of more than 250 lux during the daytime. And as Jan Denneman mentioned, preferably higher, right? So I think this is the bare minimum. While in the evening we want to be lower, and so lower than 10 lux. So that's really a big gap. And then at nighttime, so in our sleep environments, even lower than that, right? So less than 1 lux melanopic EDI. So how can we help achieve that from a light source perspective? Well, I think there's two main elements that I briefly want to bring into the discussion today. So one is spectrum, which we have already discussed today, but the other one is spatial distribution, which I think is also very important. So first about the spectrum. So what you see here on the left-hand side is the action spectra for the different photoreceptors in our eye, and also the photopic response curve. And this bold one here is the melanopic sensitivity curve. Right? So that's the one. That's basically the sensitivity of the IPRGCs that regulate a lot of your like internal body clock and internal processes. So we want to make sure that we optimize the light to for that specific input to the system, right? And so since it's on the short end of the wavelength, so on the blue end of the wavelength spectrum, so one way to change the blue content is by changing the CCT of your light, right? The color temperature, and for like broadband radiators, like a black body radiator here, or also a daylight illuminance, this is a very clear correlation, right? So you can see this nicely follows that if you increase your CCT, then you increase also your melanopic daylight efficacy ratio. And so we can do that. So one way to do that in LED systems is by using tunable CCT systems, right? Which exist on the market today. So I'm showing one example here, and you see that indeed, if you have like a broad, reasonably continuous spectrum, then yes, changing the CCT nicely follows this increase in melanopic DER. And so with that, you can get about 3 times dynamic range, right? So from here, so the lowest CCTs to the highest CCTs, that's about a 3 times difference, right? So another way to look at this is, if you don't want to change the CCT, but we can still play around with this melanopic content of the spectrum, right? And so that is what we do with the engineered spectrum LEDs that we make, and that some other LED manufacturers make as well, where we try to enrich the cyan content of the spectrum specifically, because that's where the peak of this melanopic sensitivity curve is. And then what you see when you compare it to a standard, for example, ADCRI LED, is that you can increase still significantly the melanopic content, right? So you get an additional about factor of 1.5 on top of the CCT tuning. So those are some ways to change your melanopic content through spectral design. But I think one big takeaway here is that this is very nice, but it is still all within one order of magnitude, right? And as you just saw, we want to be like above 250 lux melanopic EDI during the day and less than 10 lux during the evening. So that's already more than an order of magnitude. It's closer to 2 orders of magnitude. So spectral tuning alone is not enough. And so we need to also be able to dim or boost light levels. And when you do that, spatial distribution becomes very important to maintain visual performance, but also to make sure that the lighting systems are still efficient and we can maintain high efficacy. Because the light distributions that you need for a high dose of melanopic EDI are different than the ones you can use for a low dose of melanopic EDI. So here is an example of a light distribution that's very suitable for high melanopic EDI. So you have high or large surfaces here that are overhead, that are in direct view. that produce a lot of light. Since they are relatively large surfaces, they are not too glary, but they can still produce like a high illuminance, vertical illuminance at your eye level. Right? Here on the right-hand side is a system that might be more suitable for like evening light with low MEDI dose. So most of the light here is indirect. You're lighting only the areas of interest. There's very little direct light into your eye. So this is very suitable for low dose. And so you can see that those, you cannot just swap those, right? So you can imagine if you would try to create very low exposure with this scenario here, you would turn down the lights, but you wouldn't really see very well on the table anymore. And the other way around, if you would increase the light levels here by a factor of 10 or 100, it would be horribly glary because they have all these very bright spotlights. So light distribution is really key here. So how can we support this from an LED perspective and from a light engine perspective? So a couple of key technology elements here. Light guide plates are a very practical way to achieve low glare, large area sources with low luminance. That, for example, could achieve like a lighting design like this one shown here. So it's basically, this is an edge-lit light guide plate where you have extraction features here that extract the light over the whole area of the light guide plate. So making sure that the glare is remains low, and we can these extraction features, they can be designed to give all kinds of extraction or light distributions, like intensity profile. So for example, here in this case, it's a bat wing profile, sending light preferably to the sides, so you can get a lot of like vertical illuminance here that supports with your circadian entrainment. Another element that I think could support these kind of designs is digital projection mini or micro LED modules. So basically, what we do here, and we're already doing this for automotive lighting, for adaptive driving beam headlights, for example. So these are arrays of LEDs. So they're basically pixels that can be turned on and off or dimmed individually. And so by projecting that array or an image of that array into the far field, you can very precisely tweak where the light is going. So this is useful for automotive applications, but I think there's also a place for this kind of technology in general lighting applications, because we can send the light exactly where we want to send it. So it helps avoid glare or waste of light into areas where we don't want it, and still achieve these light levels that we need for human-centric lighting. So I think these two together, they can also be integrated. So light engine integration is another important aspect. So by combining these two, I think you could make a very simple artificial skylight. I think nowhere near what Paolo just showed, which is absolutely amazing. But I think this is kind of a first step, right? So this is I think eventually, or so you can get very similar light distributions from these kind of integrated light engines, right? You can use light guide plates to create the diffuse light that's more like the sky, where you can have your CCT changing depending on the time of the day, and then you can have more directional light, which is more like the sun, which helps you maintain a functional light source for example, task lighting. Right? So I think this kind of combination of these concepts and integration gives a lot of possibilities for human-centric lighting. Yeah, so those are my 2 cents. I just wanted to throw this in for technology elements that I think can contribute. So I'm looking forward to questions and discussion.
Thank you very much for being with us. Lumileds is an example. I worked for many years at Eindhoven. I worked for many years with companies who work for Philips. This is the story that I would love to tell, how Lumileds was created. But today we are here to make Lumileds greater. So can you help me? Can you give me 1 or 2 challenges in which the EPIC members can help you? That's what we call the EPIC question.
Right. So yeah, so on these technologies, I think there's still a lot of room for improvement. So I think that in terms of maturity, we're quite far along, or what was really driving these applications today is automotive headlighting in terms of the projection. And then, for light guide plates, this is more for general lighting, but I think there's also a lot of room for improvement still. So in terms of these mini and micro LEDs, so I think there's that's where a lot of the development is going to be. So miniaturization, making sure we can meet illumination application requirements with these kind of mini LEDs, meaning that we need phosphors that are compatible with these small LED sizes. We need integration processes to put these together in a module that is compatible with the number of LEDs that we need. So it's not like a 4K display where we need millions of LEDs, but it's also it's more than just a few, right? So we need to think about, okay, how do we assemble these things? So that's an important aspect.
Miniaturization and helping them reach the high luminosity level, including the phosphors. Let me help you on that. We have a few people here in the room who can help you. I'm going to start with the material side. Francois from DOW, from Dow. How can you help? You have a question for him.
Yeah, I mean, I raised a couple of questions. I mean, the first one was on lifetime of these new LED packages. I mean, different phosphor emission spectrum. Does it affect the lifetime of these devices? And
so the spectra that I showed you. So one was the Fusion product, which has kind of a royal blue, what we call royal blue pump LED. So that's one. So that's very similar to standard white LEDs that are on the market today. And then the other one was one which, in addition to that, also has like a longer wavelength pump LED in the system. So those. So the advantage of that approach is that it doesn't involve like the shorter wavelengths, so the violet pumps, which have some of the challenges, or sometimes have challenges with material degradation. So you need to use specially designed processes for that, which is also possible. But that's a specific aspect that needs to be addressed in development of those LEDs.
And we go from the material to the molding. We actually have Rock Tool in the room. Lennart, is there a room for cooperation here? Can we do something together?
I think so. May I share the screen with you all?
Yes, please.
Let's see. I have that. That should be.
Bottom of the Zoom window, there's a green arrow up. You press it, and then you choose the window you want to share with the universe.
Yes. Do you all read it?
Yes.
Yeah. Most LEDs are behind, and most LEDs require a lens in front of it. It could be front headlights on a car, tail lights on a car. It could be street lights. Most of these are molded. Sometimes we want the light to be distributed in a nice to human way, meaning that we don't want the sharp, sticky lights coming to us. We want to write an optical recipe for the light and how it's distributed. And if we look at how it can look, we have this row of LEDs behind a plastic lens. It's also represented by the green line here. It's sharp points using nanotexturing and a molding process that allows that nanotexture to be replicated properly. We can get this even result of the light instead. Okay, it could be used for light diffusion, light guidance, or reflection when that is the desired thing.
Let me ask you a question. So I am amazed by the diffusing technology of Rock Tool, and there's many people who are going to contact you afterwards. But for the lighting applications that we are dealing today, let me ask you out of the blue. Thermoplastics of silicon or silicones?
Silicones, thermoplastics, and when applicable, thermosets.
Politically correct answer. I like it very much, Lennart. But I'm going to come back to this topic after the presentation from Hela. But before that, today we started with human-centric lighting, and then we are going to talk about their application on the medical segment. And for that, we have a company who is making a very big difference on that sector. We have Luminus in the room. Robert, thank you very much for joining the meeting today. Let's find some cooperations here. Show us something, of course, ultra-fast photonics, that we can help us do some business.
Sure. Yeah, we are doing a lot of stuff for medical applications. By the way, very interesting presentation today on human-centric lighting. The parts that we are developing are not specifically only for medical. I'll share you some of this, share the slide of the presentation that I can give you. Let me see.
Button is on window, share screen, then select, very important, select the window that you want to share with us. It doesn't do it automatically or by default. So far it's been fascinating, but I really like the topic of our silicons versus thermoplastics. We're going to have one event only for that, because I really, really want to know. And glass, Luminus, how can you help us? How can we help you?
So you can see here the salute LEDs for physical and emotional well-being. That's what we have presented on Lights and Building in 2018, feels ages away. You can see here our human-centric salute mid-power LED. And the difference is basically that we are creating typically LEDs that are at 6,500 Kelvin, having a high M/R ratio, but that is not very nice light, not very comfortable light for people to work and live under. So we have created a 5,000 Kelvin LED with a very high melanopic ratio. So you can see typically this 5,000 Kelvin is around 80, 82. And now we created a 5,000 Kelvin close to 1, it's 96, which is the level that you have at 6,500 Kelvin. Same we did for 4,000 Kelvin. So we are creating basically light that is comfortable for the person, but also keeps the person more alert. And this one is being used by a couple of customers, and it's in compliance with the well building standard and also the UL guideline. So also keep in mind that we're trying to create a higher R9, which is better for the people to work on, you don't look so pale and bluish. I wanted to show you another thing, and that's what we created based on using a cyan chip. So this is our perfect white spectrum, where we have created a product where we fill this gap that you can see here, which is typically with LEDs. This is a standard 3,000 Kelvin 80 Sti. So we created our perfect white where we have this, and then it becomes a more full spectrum. And we also enhanced here the R9 level in the area of around 660. And therefore creating a product which is perfectly usable for museum lighting. And you can see here the differences. So on the left, you can see the standard 3000 Kelvin 80 Ci. On the right, you can see the perfect white. Something else that we're developing, which is even further in this kind of spectra, which is great for different applications. This is what we call our smooth spectrum. This one is on the black body, where the perfect white was below the black body. And this one is even based on 3 pumps. So you can see that this one is not only having this cyan pump here, but also in this area here around 430, we have another pump. And with that, the reference source here is halogen. You can see this is almost perfect matching the halogen source. And we're having this one in different color temperatures. So you're creating almost, well, it's reduced blue light. It's based more on the cyan and near UV pump that you see here. So that's in a nutshell basically what we're doing. This can be used, of course, in hospitals, but we also see a lot of clothing, high-end shops using this. Schools are also an interesting application. Yeah, you name it.
Thank you very much, Robert. Is there anything that the other companies can do to help you? This is an association focused on collaborations. Give us one challenge.
The challenge that we're seeing is that it's difficult to find a killer application where we really see human-centric lighting being successful. So we see a couple of small projects, but
I think that's a challenge that we all have as a community. I can tell you that for many reasons, I do believe that automotive is going to drive this. And the reason for that, you're going to hear on the next 2 presentations, Hela and AUDI back to back. Let's start with Hela. Thank you very much. Thank you very much, Arvid. So thank you very much, Mathias, Niedling, for being with us with Hela. We are at the bottom half of the meeting right now. We want to hear how we can help you. You are the head of research at Hela, so you are the best person to answer the epic question. Mathias, the floor and the attention of everyone goes to you. Mathias, we can hear you now, I believe.
Can you hear me now?
Loud and clear.
Can you hear me?
Yes.
Loud and clear. Okay, sorry, I didn't get it. So now I have to share my screen. Thank you for the introduction, and I think it was a very good transition from the last presentation. Today I want to speak about human-centric lighting for automotive application. Is it a realistic benefit? And the main question is not on a technical solution. It's, as I said, on the application, and there are some challenges in the automotive field. But first, I want to introduce you the LEB. What is the LEB and how is it linked to HELA? The LEB is a research institute for automotive lighting and mechatronics, which is operated, of course, by the HELA, together with two universities, the University of Paderborn, as well as the University of Applied Science, Hamm-Lippstadt. And we are working within a research platform dealing with topics on automotive lighting, for example, smart headlamp systems or high-resolution headlamp systems, but also on optic topics like the usage of holograms for optical functions. We are also working within a research network with other universities, and this is primarily for the supervision of our PhD candidates, but also to go with them in further discussions on lighting topics, of course. Yes, and I'm hitting the LEB now since 3 years and 2 months, I think, for the HELA. So now let's come to the topic, human-centric lighting. What does that mean? I think we can shorten update. We heard a lot of points before, and we all know that light has an effect on vision, light has an effect on emotion, and light has, of course, an effect on the body, so on alertness and cognition, for example. And this is the interesting point here in this moment. So, of course, vision, you know, we need light to perceive our environment visually. I think there are no further needs necessary. And we also need that light creates emotions in all of us. So a warm fire in the evening is a completely another feeling, a completely other emotion than a cold white fluorescent lamp in the same setting, for example. And also this topic effects on the body is not new at all, but since we know that there is this special receptor in our eye, the so-called intrinsically photosensitive retinal ganglion cells, there was a lot of research done, and we have an increased understanding of the effects of light on our body. We know we can shift our circadian phase, our circadian rhythm with light, and we know also we can support, for example, the driver in a car with light to increase his alertness, for example. So to bring that together with automotive lighting, I start again with vision. Of course, we have our headlamp systems, and we need the headlamps as an artificial light source during nighttime to orientate in our environment and to give the possibility to drive the car, to see objects and details during night. But it's also good to have light inside the car to give orientation in the car, because when you look for things inside the car, it's good to see something there, but it's good to make the light not too bright. The color of light, I said it before, also creates emotion. And for example, there are some people around me, they prefer a bluish light via ambient light. I, for example, prefer a red or a warm orange light at night to have a feeling of relaxing. Now the yeah, for me today, most interesting part is the effect on the body. And of course, this would be a really great benefit to support the driver's attention, to support the alertness of the driver. But I want to ask the question, is there really a realistic chance to do that? Can we really activate the driver at night with light? And that brings us to the question, what determines these effects on our body? And we heard that also before. There are a lot of influencing parameters. One is the direction of light, as we also heard in the presentation before. We know that these cells are located in the lower part of the retina. So light from the upper part of the hemisphere is said to be more effective than light from the lower part. So this green area here, this should be the most effective area for the direction of the light. We also know that these effects depend on the spectral distribution of the light source, as we heard several times before. And yeah, you know now, especially in this bluish, in this short wavelength radiant part, this radiance is most effective. So it would be good to have a high amount of this radiance. There are also a lot of other influencing parameters like chronotype, for example, this time we spend outside during the day. When we woke up in the morning, how much coffee we had. It's really multidimensional, and to come to the end with this overview slide, yeah, I want to close with some planning recommendations we also heard before, and these are for general indoor lighting during daytime. So they recommend 800 to 1000 lux horizontal, resulting in an illuminance at the eye of 250 lux. So this is for daytime, and the question now is that a realistic value? Is that the realistic light level in such a scenario as you can see here, for example? So this is a possible application for interior lighting of a car. I hope you can see it in the picture. And it's an exemplary driving scenario which we created in the HELA laboratories to make investigations on human-centric lighting. So what you see here in the upper part of the picture is a spectral tunable light panel to set a corresponding illuminance at the driver's eye. And yeah, in the background of the picture, there is an object, because the most important part here is the driving task. And the most important part is the detection of objects and the orientation in the traffic area during nighttime. And yeah, the question is it possible to set 250 lux, for example, to create effects on the body while driving a car? I have a colleague, he's a little bit older than me, and he says, when I drive the car at night, I will absolutely no accept any light in the interior because it disturbs me. And this is the question we have to balance out for an application of human-centric lighting in the interior car. So questions regarding activating effects for us are, how much light is needed first to stimulate the driver's attention? At night, maybe we don't need this 250 lux. Maybe we can just set up 50 lux or something like that. But to see really verifiable effects, I think we need a high amount of light. And then there are two other questions. First, how much light is acceptable without disturbing the driver's sight? This is the most important fact while driving at night. And second, how much light do drivers accept as interior lighting in a nighttime scenario? So on the one hand, we have to check if this additional light source maybe is a glare source, which impacts the driver's sight. And on the other side, this psychological fact, how much light do we accept in an interior, in a car's interior while driving at night? So to come to the end, human-centric lighting in the sense of activating the driver would be a really great benefit for automotive interior lighting. But today's know-how about needed light levels and the lighting systems for verifiable effects is still missing. And yes, what can we do for you? We can support conception and implementation of such lighting systems. We can evaluate these lighting systems. This is not the problem, but it would be good to have more know-how of needed light levels and settings to really support and assist the driver.
Thank you very much, Mathias, for a great presentation. Thank you for being with us. Of course, there's a lot of questions for you. I'm going to ask you first the epic question, which is, how can we help you? Give us a couple of challenges that the epic members can help you with.
I think it's the same topic than the speaker before. We need the application. We need to know how we have to concept the lighting system and what how can it be integrated best in the car to support the driver and to create the really best benefit.
All right, so let's go with the questions. The first one is coming from Austria. Joanneum Research is in the room. Tell us now what's on your mind, Franz.
Just maybe a hint. Because, yes, when all these questions about alertness with human-centric lighting, there is not really scientific consensus. So you can find a lot of studies that say, yes, you can increase the alertness with light. Other studies say, no, there is no effect of alertness on light. Now, in the meantime, there are also meta-studies out that compare different studies. And I think the final conclusion and maybe the latest consensus is, yes, maybe it's possible to have some effect on alertness with light, but only in case that the people are very, very tired. So I wanted to ask, when you're doing your studies, do you also take into account if these people are, let's say, very, very tired, or if they are relaxed, they stand up and they, let's say, they slept a few hours before they are driving, or that they are really, yes, were awake for, let's say, 24 hours, and to check out if there are some differences in the possibility to enhance alertness.
So here at the LED, a study was done, it was before my time, years ago, and they checked really the melatonin in the blood, and they created no effect. And the last study we did, it was just the acceptance of the illuminance level at the eye. So it's a really complex part to study all the things. But there was also a study from the colleagues from Daimler, I think, within a truck setting and also within a car setting. And it was a really big study, and they showed small effects. So maybe it could be possible, but it was not really during nighttime. So there are some open questions. But yeah, when we are talking about human-centric lighting at night or talking about these effects on the body, then of course we have to take care of these. And maybe it's also possible, I think it's not answered right now, that also a psychological effect can enhance the alertness, for example.
We have another question for you coming from... We have another question for you, Mathias. You're very popular. Another question coming from Kimoto, provider of thin film technology. Christoph Boschardt, what's on your mind?
Yeah, thank you for the great presentation so far. So I'm wondering, we see a big trend in increasing sizes of displays for information. The speedometer has gone digital. We have the big entertainment and navigation systems. They all emit light. So is there also some work done on synchronizing the light colors of the displays with the interior light for nighttime driving?
I think this would be a really good chance to synchronize the systems. Yes, there are more displays and they are getting bigger and bigger, and it's a really interesting trend. I think they will be dimmed in the evening or in the night. So I can't tell you now how much light do they bring to the eye. But yeah, it's an interesting idea, and I think it's a must for future lighting interior systems when the driver needs to drive the car. Then we have to synchronize the system and to check if there's an influence or not.
Matthias, you're super popular. There are so many questions for you. Let me remind everyone that on the 27th of September, we have our meeting on head-up displays. We're scouting technologies for this now. But Matthias, I want to introduce you to a company that I know you already know, but there is clear room for cooperation here. Jet Light. Akim, we met 2 weeks ago and I was amazed. Tell us how you can help the companies in the room and how they can help you.
Yes. Hi, Matthias. Thanks for your speech. And just to answer a bit of your question, you asked if 250 lux would be usable in while driving. So we do not recommend to use it because we did a study in aircraft cockpits where pilots had to answer if they could use 250 lux or also lower intensities. But we usually recommend to use lighting while not driving, so before or after, or for example for autonomous driving. And we do the software for different use cases, and therefore it would be very interesting to go deeper in research.
If we don't see the slide, we cannot picture it in our head. Sana told me that you have one beautiful slide to show us, right?
If I have a slide or in the background, or what do you mean?
No, nothing. You have some slide to show to us? No.
Not in the short run, but I can provide later. So,
okay, yes, because I really want everyone to understand exactly what Jet Light does and how we can help the companies in the room. But Akim, Matthias.
What we do the software for hardware, how to use human-centric lighting, and to bring it directly to the chronotypes related into cars, into aircraft, and so on.
We have heard half of the story now. Hela, allow me to go to Audi. Yeah. Because with this, we can get the full picture, and that's how we like it at Epic. Allow me to go to Audi now, and allow me to give the floor to our automotive Epic member. Yes, Audi is a member of Epic. Arvid, thank you very much for being with us. The floor is yours.
Thank you. All right. Yeah, thank you for the kind introduction. I hope you can see my screen now.
Crystal clear.
Yeah. Hello, everyone. My name is Arvid Niemeyer. I'm an engineer at the interior lighting department at Audi, and today I want to give you a brief overview of what we have done in regards to human-centric lighting and how we approach this whole topic. First of all, let's start with our general motivation and how we approach interior lighting. One of our main goals is to create a adaptable interior lighting that is able to change depending on the mood you're in, depending on how you like it. Like Mr. Niedling said, he prefers light to be orange, others like it bluish, and so on. And we'd like to change the light in order to create this ambience for a mobile working and living environment, which can be seen maybe in autonomous vehicles in the future. For this case, we'd like to also use non-image forming effects or human-centric lighting, and specifically the alerting effects of light to create several situations where you can change the light for maybe productivity or relaxation. Here on the right-hand side, you can see the upper right-hand image with the bluish light for productivity, or then on the lower picture would be the warm reddish light with the lack of bluish light. So what has previously been discussed is that most of the studies, that have been done in regards to all those effects, they have been done in, I don't know, hospitals, in schools, in office environments, and there's, little to none research that has been conducted for the automotive sector. And so we aren't that sure how we can translate those findings we have from offices and so on into the automotive sector. But looking at our vehicle interiors, there are some limitations that are quite obvious. looking around us, everyone is sitting at home, probably in some kind of room. We have a huge ceiling around us, above us, we have those walls around us. But when we sit inside of a vehicle, we don't have that much space. We have our small headliner, we maybe have the A, B, and C pillar around us, but that's it. So we have to use that space in order to, well, integrate our light sources in there. And looking at the previous presentations, it was said that we need bright light and we need large light sources. And those things combined are kind of difficult in vehicle interiors because space is limited. Thus, we have to downsize our light sources. And by downsizing our light sources, we create brighter light sources, which will induce glare. So that's a problem for us. Then additionally, if we look at the use case of, the vehicle itself, typically in times when we don't have Corona, it's probably driving to and from work. So the passengers most of the time use the vehicle in the early morning or in the evening for, I don't know, 30 to 60 minutes, maybe around that. So what did we do in order to see if we can translate those current scientific findings? We conducted several studies. As of right now, there are 3 over the last couple of years, where we tried to implement some of those findings in a way that could also be translated to an automotive surrounding. We conducted those studies in labs, as you can see on the right-hand side. So in the first image on the upper right-hand side, we set up a small office environment, while on the lower right-hand side, we implement this whole setup in a driving simulator. What did we use in case of lighting itself? So you can see those huge lighting panels above the head of the test persons. Here we try to take a look at several solid angles. The solid angle you can see here is about 0.44 steradian, and the smaller one we used is 0.05 steradian. Just to give you a better imagination of the size, just imagine an A5 piece of paper. That's about the size of the small light source. Then we used 200 lux at eye level, which we learned today might not be enough. But as I said, a limiting factor inside of the vehicle is glare. And we tried to reduce glare by lowering the illuminance. Then we also used 6,500 Kelvin. Lots of blue light in there. And just to add here, if we translate those 200 lux into melanopic lux, we were at about 170 melanopic lux. How long did our passengers stay inside these cabins? During the first and second study, our participants were exposed to the light for about 35 minutes, while in the last study, we extended this time to 90 minutes. And this took place in the early or late morning, depending on which participant was doing the test. So what did we focus on? We know that blue light can activate us, can change our emotions and so on. So we focused on those activating non-image forming effects and tackled those things with the questionnaires regarding sleepiness and alertness. But also we've taken a look at objective tasks, especially working memory, sustained attention, and even reaction time tasks. But as I said previously, 200 lux may have been too low. And this was also seen in the results we were able to get. So in our case, during all those 3 studies, we were only able to show a significant improvement for the subjective alertness in the first study. And here to add, our participants weren't sleep deprived, so we tried to cover a broad spectrum of participants and not only focus on one tiny group. Then additionally, looking at the objective tasks, we were able to show that there is a small positive trend for this whole thing, but again, nothing significant. what does this mean for human-centric lighting in the automotive sector? Well, for once, the parameters we've chosen might not have been ideal. As we've learned, higher brightness levels could be better. Maybe we have to rethink the way we imagine the interior. Here we focused on two solid angles. Maybe, as you can see on the right-hand side, one has to implement even bigger light sources in the vehicle interiors, which might be a possibility in the future when we look at autonomous vehicles and not so much on vehicles where you're driving yourself. But if we take a look at the current state of automotive interior, yeah, one has to question if the current findings on non-image forming effects are good enough to be translated into the automotive interior. But I also think, yeah, although we've done 3 studies with not so great results, I don't think that's a conclusion to be made just yet, because I think one has to do some more long.
I think we lost the sound with Audi. That's
yeah.
impossible. The most reliable company in the world. I believe we did lose the sound. This is one of the problems of making the show live. But lucky enough, he was in the conclusion slide. Let's have a little bit of a Q&A now. And we have a question coming from CoeLux. Paolo, I believe you have a question to address Hela, correct?
Yeah, to both, to Hela and to the current speaker also. So the question concerns the type of light is more suited for alertness in driving the car or other vehicle in the night time, because I heard talking about illuminance levels, so lux or lux, but as a matter of fact, for example, in our experience when we dealt with the building, the reconstruction of the moon, so indeed there are a very few lux level, but there is some illuminance, which is very low, but the luminance itself of the moon might be a different story. So it's a very small solid angle, but both this level of luminance and also the memory effect that trigger you to remember your experience of the moon in the outdoor is extremely strong in terms of the attention. So the light can be indeed very limited flux, but the brightness of the object, even under a small angle, might be significant. So have you ever studied this topic, especially in connection with some object that triggers your memory? Because if we replace, for example, our moon with just a simple disk, it wouldn't work. So the brain really reacts to the memory as well.
Thank you, Paolo, for the comment. So while we're waiting for AUDI, there is Mathias, who has.
Back. Just reconnected.
I think Mathias from Hela would like to ask you something.
Yeah.
Mathias, I'm afraid we don't hear you clearly. There is an issue with the voice. So let me ask you the epic question. AUDI knows now how we do it. So you showed us what you can do for the others. Is there a challenge you would like to share with the audience today to create?
Yeah, so I think some of the challenges have already been answered. So one was the increased melanopic lux for the LEDs themselves. We, for our studies, had 200 lux and 170 melanopic lux. If we were able to increase that even further, that would help our studies. So that's a given. Then yeah, the second point would be to look at long-term studies, if that's something which is realistic. I don't know, in order to see if those short but frequent exposures to light will create an effect or not. And then last but not least, which is something we at AUDI have to do as ourselves, we have to maybe rethink, as I said, the design of our interior itself, if it is a solution for the future to implement differently styled light sources and not just focus on those small lamps, I don't know, like a makeup lamp and so on, but also to implement larger light sources into the vehicle ceiling itself.
All right, thank you so much. I think I'm really looking forward to go to to close the discussion with the talk from Lumission, because he will also answer some of your comments regarding the software for controlling the lights. I'm very happy to have Henk today. Henk, you can unmute. Thank you for joining us, and we're looking forward to hear your talk now.
Yes, thank you. Thank you that I'm allowed to close this event, and almost 2 hours listening. So I hope you have a few minutes more.
Of course we do.
I will share my screen with you. Here. So I hope you can see my screen now.
Yes.
Okay, a quick introduction. My name is Henk Schaap. I'm Senior Product Manager from Lumission. Lumission is a Dutch manufacturer for luminaires, and we do also development. Founded in 2010. We have only 16 employees, but all are very experienced in the lighting business. Myself, I worked for Highlight International. Actually, that is a show and entertainment lighting company. So I was in an early stage already involved in control for lighting, digital controls like DMX. Then I worked for the SLV Germany. Is one of the biggest lighting importers from Europe. I was in the innovation team, also as a product manager. So back to Lumission. I work now 3 years for Lumission, and my task in Lumission is, of course, sourcing for luminaires, following the market, and like here you can see a little overview of our products. Lumission is mainly focusing on functional lighting equipment, from panel lights, surface lights, and also downlights is our main business. And since January 2020, our company is also involved in development for smart lighting. And of course, together with smart lighting, human-centric lighting is the topic. I think many speakers before me already explained about the human-centric lighting. I cannot do that better than the people before me. So what I would like to point out is one of the difficulties for human-centric lighting is, of course, the controls. And also, what is human-centric lighting? Okay, the name itself already say it. The human is central of the lighting. So actually, also human-centric lighting is dynamic lighting. So I think all of us will agree. And beside that, the lighting should be automated. So same like the light outdoor should change by each hour. It is also important that there are many different applications of human-centric lighting, and also all the people are different, have different preferences. For example, elderly people, they have the eyes become more yellow, and they have a different they can see the light different than younger people. So also in the functional lighting industry, it is important to acknowledge this, and this makes it also very important that that you have different controls, like, for example, a touch panel like this, or even a small one like this one here, and our company, we have developed the sunlight system. Is actually a Bluetooth mesh-based control system. Actually, a light management system, and also ecosystem existing out of drivers, sensors, dimmers, retrofit, and controls. These are the 5 subgroups of the complete human-centric lighting program. And also, it is very important to that you can use products from other vendors. So many other lighting manufacturers, you can see they have all have their own system, but they in a project they cannot integrate luminaires from other brands. And I think that is one of a big challenge for the complete lighting industry. And therefore we have created the Sunlight, and with this we can also integrate and combine luminaires from other vendors. Sunlight also is we have an app, app for commissioning the lights, and we also have a human-centric lighting scheduler. Actually, it's a very simple timer, and you can choose between 12 hours or 24 hours, and per each hour you can change the CCT by yourself, and also can change the light intensity. So actually what we've done is same like our friends from LEDVANCE. It's almost a little bit similar, making human-centric lighting available in a simple way. So you don't need to be a programmer, and yeah, just connect the lights to the mains, and you can go. So that is actually in short what we can do and what we do.
Thank you so much, Henk. I would like to see if we have any question in the room. Otherwise, I give the word to, oh, I see Hella, Mathias. You are muted.
Can you hear me?
Yes, now I hear you.
Ah, okay. No, I don't have any questions. I have to.
Okay, because I see your rising hands. Maybe Jose, is it time to close the meeting? You're ready?
I'm always ready, but I would like to ask my very good friends from Lumission, because I'm very impressed with what you do. How can I help you? If you could give me 1 or 2 challenges that the photonic industry can help you with, I will be more than happy to do it.
Yes, sure. I think first of all, you already helped, because I think starting such a conversation like today about human-centric lighting is very good. I can talk hours, and with each and every one of you, I can talk hours, and I have many questions, but that is not within this topic. My question is actually to the rest of the people. Our system now is a kind of automated, but what actually is missing, in my opinion, is the feedback of the light of the environment. For example, we have already meters who can measure the light level, and we have also meters to measure the color of the light. But actually, what I would like to see for the near future is this should be integrated in a human-centric installation. So if I push the button and I say, okay, now I want to have 6,500 Kelvin cool white, how do I know that in my room, in my space, it is really 6,500 Kelvin? Because also I have the windows, which is also putting in different color temperatures and mixing. So
you don't want the average power. What you want is a cartographic map of the temperature in each point in the room.
Yes, and actually, what my wish is that the human-centric lighting Same like for example, a daylight harvesting system should also follow the color temperature of the in the room.
So I want to raise that challenge. We do have a lot of solutions for you. So I want to raise a challenge to the whole EPIC community. You know, it is 5:14 o'clock. So what I'm gonna do is I'm gonna close the meeting, but then we stay in the room here and we can continue chatting. But let me close the meeting. So first of all, I would like to say it was fantastic. It was our first ever meeting on human-centric lighting. I had very high expectations, but you guys have made it a lot better than it was. We already know that light can be customized to affect the mood. My mood was very high today. Attention level and health, but there is a big demand. We need early adopters, and I was quite amazed on how advanced the automotive sector is on this point. I also see that there is a huge photonics challenge, and it's the light source. The presentation for ZUMTOBEL was the one to remember. We need high refractive index materials, so silicones, so thermoplastic materials. We need to work with you. PMMA, we need to work with you. You have the driver to solve this challenge. And also we need less absorption and longer transmission rate, down to 400 nanometers. For me, what I do need is to continue organizing more events on this fantastic topic. What I want to remind everyone is that the meeting now is over, but the most important part of the meeting is going to start now. Now is when we do the follow-up. I want everyone to find potential suppliers and partners at these meetings. You want to get in touch with any of the participants today. They came to the meeting looking for partnerships. So you want to get in touch, all you have to do is send me an email, jose.pozo@epic-assault.com. Do not shy away from pitching your solution, because your solution could be what they are exactly looking for. And that's why they are epic, and that's why you are all epic. Stay tuned for the upcoming meetings. 7th of June, pixels, with the top pixels manufacturers in the room. And until then, wash your hands, wear a mask, stay healthy, get vaccinated as soon as possible, and see you very, very soon in our next live event. I can't wait. I need to travel. Take care of each other. Bye-bye.